In today's lesson, we're going to talk about applying the remainder and factor theorems, aka dividing polynomials in order to factor. So we're going to start off with dividing one polynomial into another polynomial using long division. Now, I'm sure it's been a long time since you've used long division, so let's review that process, because the process with using it with polynomials is going to be the same. So let's take something simple. Let's say I'm going to divide 2 into 73. Okay, so a long time ago, you'd given a problem like this, and it was really hard, and you'd practice it, and you'd say, okay, well, how many times does 2 go into 7? And 2 goes into 7 a total of 3 times, because we know that 2 times 3 is 6. And then you would subtract those, and that would leave you with a 1. And then you would drop down to 3, leaving you with 13, and then you'd ask yourself, okay, well, 2 goes into 13 how many times? And you know that 2 times 6 is 12. So you put in 6, and then you put in a 12, and you subtract that, and you're left with a 1. But there are no more numbers to drop down. Now, this is before we did decimals, okay? So this is going way back. So what did you do before you did decimals? You had a remainder, and then you'd write R1, or however your elementary school teacher had you do that. But so now you would say, okay, well, this is my answer. And maybe in some cases they, oh, well, it'd be 36 plus a remainder of 1 would be your answer. So algebraically, it would look like 73 divided by 2 is equal to 36 plus, no, this isn't really, well, we would say remainder 1, but we would include the R. I would say 36 plus 1 left over. So that would be our solution. So the idea with polynomial division is really the same thing. So let's go ahead and set this up. So the first number, our divisor, is we have a quadratic, x squared minus 2. Now you want to be careful with this, because we need to include every single term. So that includes the x squared, but that includes the x, but we have no x term. So we need to put in a placeholder. So plus 0x, and then minus 2. It's very critical that we include placeholders for the terms that are missing. And then we'd say divided by, okay, that was a really lousy divided by symbol. Let's try that again. Divided by, and then x to the 4th plus 2x cubed plus 3x squared. Now we still need an x term, even though it's not listed here, so we'll put plus 0x minus 7. And then we start dividing. Now, the crucial bit here is looking at our first term in our dividend. And we're going to compare our first term with our dividend to the first term in the divisor. And we're going to ask ourselves, what do I have to multiply with x squared to give me x to the 4th? And I simply would say, well, I would need to multiply by x squared. So over the x squared here, we're going to put in 2 x's, x squared. So x squared times x squared gives me x to the 4th. Now everything in the divisor needs to be multiplied by x squared. So that's going to be 0x becomes 0x cubed minus, and then 2 times x squared is 2x squared. And just like in our old long division problem, we're going to subtract. So since I'm subtracting, it's like saying plus negative, so it's like saying plus negative, negative, and that becomes plus. And x to the 4ths cancel out, and then we'll be left with 2x cubed plus 5x squared. And then we drop down our next term, which is 0 to the x. Now we'll look at the first term of our divisor with the first term in our process in our division problem. And we have to ask ourselves, well, what do I have to multiply with x squared to give me 2x cubed? Well, we'll have to multiply a positive and then 2x. So now we multiply everything by 2x. So that's going to be 2x cubed plus 2 times 0 is still 0. So it'll be 0, and then x and x give us x squared minus 4x. And now we subtract these guys. So the first terms cancel out. We add the 5x squared with the 0x squared, and that's just going to give us 5x squared, and then minus 4x. If we do it correctly, these first terms should always cancel. And then we're going to drop down our next term, which is minus 7. And then we're going to ask ourselves, well, what do I multiply with x squared to give me 5x squared? And sure enough, it's going to be 5. So we're left with 5x squared minus, and then it's just going to be 0x. And then 5 times 2 is negative 10. And then we're going to subtract these terms. Now I did make a mistake earlier. This should have been subtraction, so I was adding 4. So that should be plus 4x because we're subtracting. So that's why it's a good idea, because it's easy to make a sign error. So make sure you're taking care of the minus signs like so. So then I'm going to go ahead and the first terms cancel out, and that's going to leave me with 4x, and that's going to be positive 4x, and then plus 3. And that's what we're left over. It's a remainder. So therefore, now here's how we write our answer algebraically. So this is kind of like side work, more or less, but you are going to show this so you know how to, show that you know how to do this process. So the way that we would write that is we're going to, write it algebraically. We're going to say x to the 4th plus 2x cubed plus 3x squared minus 7. So we don't need to include the placeholders when we're writing it out algebraically. X squared minus 2 is equal to our quotient, x squared plus 2x plus 5, and then plus, and then this is a fraction. We're taking it's this over, well, we're dividing this into it. So we're acting like we're going to divide it even though it doesn't go into it. So we can, and we know we can stop dividing here because we have no more terms, but additionally, the degree of the divisor has to be larger than the degree of what we're left over with. So then divided by x squared minus 2. Okay, and we just write it out as a fraction, like as if we were going to divide that, but we can't actually do that at this stage of the game. And that will be our answer. And we box that in. Okay, so that's dividing using long division. Now, this next one, we're going to actually be solving. Now, we've solved for quadratics. We found the zeros for quadratics, and now we're just going to do this for any polynomial. Before I do that, division's going to play an important role, and we want to understand one thing. So, for instance, if I were to go back to that previous example with the long division, I was dividing 2 into 73, and 2 doesn't go into 73 evenly. We're left with a remainder. But if this was 72, then 2 goes into 72 36 times. So we could say that 2 is a factor of 72, because 72 would break down to 2 times 36. We just divide it in, and it comes out 36 times. So it works out. And so we're going to use that same principle, or the same idea. If something divides into something else evenly without a remainder, we know that it's going to be a factor. So for this example, we have 1, 0 of f of x equals x cubed plus x squared minus 16x minus 16 is 4. So we want to find the other zeros. So we know that one of the zeros, or solutions, if you will, is going to be 4. And so therefore, one of the factors is going to be x minus 4. Because if x minus 4 is equal to 0, therefore x is equal to 4. Okay? Now, since we know what one of the factors are, it's x minus 4. And the reason I want you to know this is that this factor is linear. Okay? Now, this is an important thing. Now, if you have a linear factor, I mean the degree of that is going to be 1, you don't have to use long division. You can use a thing called synthetic division. Now, this only works if your divisor is linear. If it's quadratic or anything greater than 1, it's not going to work. So since we can use synthetic division here, let's set it up, and I'll show you what I mean by synthetic division. So I'm going to, since my factor was x minus 4, I want to write down the 0, which is going to be 4. Then I'm going to write down the coefficients of the polynomial that we're looking for the zeros of. Now, just like long division, we want to include 0 for any placeholders. However, in this one, we don't have any missing terms, so I don't need to include any zeros. But be aware of that. Okay, now I'm going to add a line down here, so I add the coefficients, and then I'm going to put a dashed line right along here. And this is where my remainder is going to be. So here's how this works. I'm going to start off and drop down the first term. That's 1. So I'll write 1 here. Then I'm going to multiply 4 with 1 and put that product there. So that's going to give me 4. Now, instead of subtracting with synthetic division, I'm going to add these together. So when I add these together, it's going to give me 5. So that would go right down there. Then I'm going to multiply 4 with 5, which gives me 20, and then I'll put that right there. And then negative 16 plus 20 is going to give me a positive 4. So that goes right here. Then I'll multiply 4 with 4, and that's going to give me a positive 16. So that's going to go there. And then negative 16 plus 16 is 0. Which tells me there's no remainder, which tells me that this is indeed a factor, or x minus 4 is a factor of the x cubed plus x squared minus 16x minus 16. But furthermore, what we've done here is we've found out what we get when we factor out the x minus 4. When we factor out an x minus 4, so here's how I write this out. So x minus 4, we get that from the 0 of 4, but now I can write down the remaining polynomial. And here's how I do that. These are going to be the coefficients. So we're going to take the original polynomial here and we're going to decrease it by a degree of 1. So this one is x cubed, so now what's left over after we factor out the x minus 4 is x squared. And the coefficient of that is 1. And then 5x, and then plus 4. So decrease the degree by 1 and you have your coefficients, and there's no remainder in this case. So it is a factor. If there is a remainder, it's not a factor. Okay, now all I have to do at this stage is I have a quadratic, and that's a piece of cake because we've been working with quadratics for quite some time. So I'm just going to factor that, and that's going to be x plus 4 and x plus 1. And the zero product property tells me that my other zeros are going to be negative 4 and negative 1. So I would just box that in since the question is asking what are the other zeros as opposed to all the zeros. Anyway, that is applying the remainder and factor theorems, aka dividing with polynomials. I'll see you on the flip side.